I'm David Dalé, and today I on style transfer for text and how it can help controlling the style of your chatbot. Before this, I need to make a personal statement. I am a Russian citizen and I am firmly against the war and against Putin's regime. And I feel sorry for all my nation that we have allowed this. This war has caught me in the middle of vacation in Europe, but in a few days I'm going to fly to Moscow and participate in the protests. And now I feel it's appropriate time to introduce myself. So I'm David Dalé. I'm a research engineer in the NLP group at the Skoltech University, and we work on textile transfer and paraphrasing. You can read about this group at our site. Also, I'm a freelance chatbot developer, and before I have helped developing the natural language understanding engine for Alice, which is a Russian voice assistant made by Yandex. And you can find my contacts at my personal website. So I will start with discussing how one can generate responses of a chatbot. One way is to use rules to fill templates, which is the most simple and obvious way. And with this way, we can be sure that a response is correct, that it contains the correct information, as long as the rules that we use are correct, of course. But the responses will be often uniform and dull. So the other way is to use neural networks to generate responses. And nowadays, language models such as GPT are usually applied for this task of generating a dialogue response. These responses can become much more diverse and interesting than template-based responses, but the responses may be wrong in many ways. First, they can have bad style, for example, be toxic, because these language models are trained on lots of data in the internet that contains some bad language and bad replies. And also they can have wrong meaning. By this, I mean not the meaning that you would intend to put into your chatbot. So another way is a hybrid response generation. So this third way is used less often, but I think it has a great potential. So we can generate correct responses using rules and templates, the first way, but then we rewrite these responses using neural networks made for paraphrasing. And these can give us more diverse responses because we can rewrite the responses in multiple ways, and we can sample from these networks. And we do not lose control over the content because the content of the responses is generated using rules. By content of a text, I mean its meaning, its semantics, as opposed to style. Style is a consistent way of expressing the meaning. So the same meaning can be expressed in multiple ways. So we compose the meaning using rules, and then we rewrite this meaning in a particular way using a network trained for paraphrasing. And if we have a right model, it can also control the style of this response. So to do this, we need a good paraphraser model. Paraphrasing means given one text X, producing another text Y with the same meaning. Nowadays, it's usually done with sequence-to-sequence neural networks, such as T5, fine-tuned on a large data set of paraphrases, such as Quora questions titles or polls by Google. And if there is a parallel corpus with different styles, we can train a model to perform something like translation. For example, from formal English to informal English, if we have such a corpus. So such a model could change style in some predictable and controllable way. There are examples of such parallel corpora of text with different styles. For example, there is a model, there is a corpus GIAFC for formality style transfer. It consists of many thousands of short texts manually rewritten by crowd workers from informal to formal style. So given this corpus, we can train a sequence-to-sequence model to paraphrase text and make them more formal or more informal. There are other works that try to generate such parallel corpora automatically without using crowd working. For example, there is a paper reformulating unsupervised style transfer as paraphrase generation, and it takes a corpus in a particular style, then it paraphrases this corpus and trains the model to reproduce this corpus. So as a result, we get a paraphrasing model that is good at generating text in a particular style. An example of such tasks on which our team has worked for more than a year is text detoxification. So given a toxic text, we may want to rewrite it in a less toxic way. One usage of this model is to suggest social network users to post less toxic versions of their comments. So given a comment that the user has typed, the service can suggest the user to post another comment with approximately the same meaning, but rephrased in a better way. And another application is for chatbots. So if we have some chatbot that can potentially generate toxic responses, if it uses a language model, we can rephrase the responses of this chatbot in a less sensitive way. And this problem is explored in my paper, text detoxification using large pre-trained neural model that I have presented at EMNLP in the last year. So this problem is a special case of a text style transfer problem. Given a text X, generate the new text Y with three properties. First, it should have the desired style, for example, non-toxic or formal, or I don't know, style of Lord of the Rings or whatever. Also, the meaning of the text Y should be close. Ideally, it should be identical or just very similar. And also, the text Y should look naturally as if it is written by a human, because some models can actually break a text to make it look unnatural. And the question is whether we can achieve it without parallel data. Yes, but the current research on text style transfer is really strange. We have collected some examples of paraphrase from several papers, and these examples are considered by the authors successful, but they actually change the meaning of a text. So, from example, a paper that tries to paraphrase the text from male to female style replaces beard with hair and Viking with a mermaid, which is related in some way, but actually a different meaning. So the most default models of unsupervised textile transfer without parallel data are weird, but there are one of them I have already mentioned, the paper by Krishna. Another was proposed in our paper. But first, let's discuss the baselines. We can just remove all the words that are potentially bad using some classifier of bad words, or we can replace the whole bad text with a good text taken from some collection of nearest neighbor search or some similar technique. And we can try to replace only bad words with similar words that are less toxic. And in some contexts, it really works. But there are better solutions. The best solution is actually to collect a parallel corpus using lots of toxic texts and crowd workers who rewrite this text to a neutral mode and then train a supervised model, like for translation sequence-to-sequence model, to detoxify them. These produce the highest quality, but it's an expensive way because we need to generate a lot of crowdsourcing responses, and many of them will be filtered out because of low quality. because some prod workers are cheating and some may just don't get the task well. And another way is to still stay at the unsupervised side, but combine a paraphrasing neural network with a language model conditional on styles, which is what I propose. But before this, I need to tell a little bit how actually neural models process text, because it might be not obvious for the least technical listeners. So there are neural models like BERT that read the text in both directions, looking at the words on the left and on the right, and they are usually trained to fill the gaps. Another type of models like GPT, they just try to predict the next word in the text, and they look only in the left direction because they produce the text sequentially, autoregressively. And there is a third type of models like T5, which is actually the classical transformer introduced for the translation problem, which consists of both parts. It has an encoder that reads the input text in both directions, and it has a decoder that generates the new text. And the decoder looks with its attention into the whole text by encoder and into the left part of the text by the decoder. So we can train the GPT model to generate texts with a particular style. If we have lots of toxic text and lots of non-toxic texts, we can train two GPT models. One will generate toxic texts, another will generate non-toxic texts, but we will not be able to control the meaning of these texts. Or we can train a T5-like model with an encoder and decoder for a paraphrasing task. And actually, there are several such models in the open source, and we can take any one of them. The encoder will look into the original text, and the decoder will look into the part of the new paraphrased text, which is already generated, and it will preserve the meaning of the original text. But if we don't have a parallel corpus with different styles, this model will not control the style, but they can be combined. So this is the para-GDI model, when GDI means generative discriminator. We have an input text commandment, the article was complete trash, as an example, and we try to generate the new text, man, the article was a whole, and now we need to generate the last word so that we preserve the meaning but change the style. And how we do this? We can try to run our paraphraser on this text. It predicts the probability of the next token YT given the prefix, the already generated text Y before T. T is the current token, and the original text X. So it can produce a distribution over all words. So the most probable word is trash, which is the word in the original text, or crap, which is its synonym. But we also have other model words like mess, hell, bunch, or some words that can actually replace this one. And the most probable are trash, crap, mess, or damn. And most of them are toxic, but some of them are less toxic, and we want to use them. How do we do this? We apply two more models, which are language models, like GPT, and they are not conditioned on the input text X, but they are conditional on style. So one tries to generate toxic texts, and another tries to generate non-toxic texts. And they produce two more different distributions, which assign high probability to toxic or to safe words. And then we can combine all these three distributions. So we want to pick a word with a high probability from paraphraser, low probability from a toxic language model, and high probability from a non-toxic language model. For example, we can just subtract the probability from the toxic language model and add the probability from non-toxic language model, and add the probability from the paraphraser and get the new distribution where the most probable word is mess, and we just insert this word. So this word both preserves the meaning and is comparatively non-toxic. Actually, the idea is borrowed from the paper of Krauss, but in their paper, they don't use a paraphraser. And instead of adding and subtracting the probabilities, we use the Bayes theorem, which makes the whole process a little bit more rigorous and actually works better. And so far, we have only models for English, but we are trying to do it for other languages. And if we compare this model with baselines that just try to replace some words or phrases, we see that actually the responses of ParaJedi are a little bit more fluent, although they are not perfect. And the manual evaluation confirms that this approach preserves the meaning better than other models. But actually, if we collect a parallel corpus made by crowd workers, then the model trained on such a corpus will preserve even better this meaning. And currently, we are working on even better methods based on reinforcement learning and some other things on how we evaluate style, content, and naturalness of texts. In the future, we want to try to create high-quality models for transfer of multiple styles and languages. We want to improve the diversity and content-preserving properties of such models, because some of them generate not very interesting paraphrases, which are similar to each other, and some of such models, when we try them to become more diverse, they tend to lose part of the content too often that we want. And one more idea that we are testing is combining style transfer models with a chit-chat generation model. One way to do this is to attach a Jedi component directly to a general conversation model instead of a paraphraser. So we still have the conditional language models, but instead of a paraphraser, we have a dialogue response generation model. Or we use a reinforcement learning model to fine-tune a chit-chat model. And actually, I have already experimented on this a little bit, and it works. This is my last slide. I give links to two important papers on this topic and to my own paper. You can contact me, or you can read about our group. Of course, all of this is relevant only if we find a way to stop the war. So just wish us all luck. Thank you. Now I'm going to answer some questions. There is a question whether styles can overlap, for example, formal and non-toxic and Lord of the Rings. Yes, styles can overlap. There are styles that are mutually exclusive, but most styles can overlap. Actually, with the Para-Jedi approach, we can combine more than 3 models into one generator, so we can try to generate responses controlling several attributes. And there are other papers that try to combine different attributes when generating new texts. Thank you for the question. If there are any other questions, I'm going. Okay, thank you very much for listening, and goodbye.